Hello everyone. You have these worksheets that's working with digital to binary, and I wanted to do a instruction on how to do those. So let's start our converting from digital to binary. The first number we'll work on is the number 3. Now you'll see that we did talk about the cards in the previous video you were supposed to watch. So this is how you would do this. We are trying to convert a 3 into binary. We look at the 16. 16 is too large for the 3. So we're going to turn that over. Anytime you turn a card over, it becomes a 0. Any card that stays up becomes a 1. So now this one has 8 dots. 8 is larger than 3. So we're going to turn that over. And we'll proceed to go down the line. 4 is larger than 3, and we'll turn that over. 2 is less than 3, so we'll keep that. Do we need 1? 1, 2 plus 1 is 3. So that is how we would write that in binary. In binary, it would be 0, 0, 0, 1, 1. Okay? And it is following the dots. This is a 0. This is a 0. This is a 0. And since this card is being used, it's a 1. And then since this card is being used, it's a 1. Okay, let's try this again with another number. Let's look at the number 9. Okay, again, we will go through the same process. 16. 16 is larger than 9, so we'll flip that over. 8 is not larger than the 9, so we keep it. 8 plus 4 equals 12. That makes it greater than 9, so we'll flip that over. 8 plus 2 is 10. That is still greater than 9, so we flip that over. 8 plus 1 equals 9. So the binary code, again, is going to be matching those cards that are turned over. So the 0, 0, the 1, the 0, the 0 again, and 1. Again, any card that stays flipped up is a 1. And any one that stays face down is a 0. Okay, let's try another example. Now, 16 probably looks like it's going to be difficult, but it is not. We start here at the end again. Remember, the next card would have been a 32, but we're only working with 5. So this card has 16 dots. 16 is equal to 16, so we keep it. If we add 8, we'll make it too large, so we flip it over. If we add 4, it'll be too large, so we flip it over. If we add 2, it'll be too large, and we flip it over. And if we add 1, again, we flip it over. So our binary for 16 again is matching. 1, 0, 0, 0, 0. Okay, so again, this being 16 and then all of the following being turned over turns those to zeros and turns that one to 1. So remember, binaries is only in zeros and ones. So let's try another number. Let's do 7. Okay, 16 is larger than the 7. We flip that over. 8 is larger than the 7. We flip that over. 4 is less than 7, so we keep it. 4 plus 2 equals 6, so we keep it. 4 plus 2 plus 1 equals 7. So the binary for that one is 0, 0, 1, 1, 1. Okay, now we're going to do another number. So by now you should be seeing how to take care of this. Okay, number 10. Now, again, we start with the highest number. We have our 16. 16 is larger than 10. And this is our last number. 8 is less than 10, so we keep it. 8 plus 4 is 12, so we take away the 4. 8 plus 2 equals 10. Then we go 8 plus 2 plus 1, which makes it 11, so we flip it over. Again, this is 0. In binary, remember it's 1 and zeros. This is 0, 1, 0, 1, 0. So that is your binary code for the number 10. So we have our decimal number and we have our binary number. I hope this helps. Thank you.